Hello class, this is lesson 16.1, properties of logarithms. So the learning goal for this lesson is to know how to solve problems involving logarithms and exponents. What we're going to be doing is we're going to be looking at some properties of logarithms and using those properties to, one, expand logarithms, and two, combine logarithms. And we're going to start on page 28. Okay, so let's go through these properties one by one and take our time with each one. So these properties apply to all logarithms. The first thing that we're going to do is we're going to look at the definition-based properties, which I wrote here on my paper. So the first definition-based property is that if you have a log base b of b to the m power, that is just equal to m. So what actually occurs is that the log base b and the b cancel each other out, and we're left with m. Another property, definition property, is if you have log base b of 1, then that is equal to 0. And the last one is if you have log base b of b, that is equal to 1. So we're going to just keep these in mind when we're working on some problems. They might appear, maybe they might not, but we need to look at these. Okay, the next property is the product property. Now, product property, you guys think of product as multiplication, and this is what this is. If you have log base b of m times n, we can expand this to log base b of m plus log base b of n. So we could go either way. We could go from the separated to the combined, or from the combined to the separated. So use this property either way. But product, we have an addition separating these two logs. The next one is quotient. Now, quotient property means the division property. So an example would be if you have log base b of m divided by n, this is equal to log base b of m minus log base b of n. So we subtract the numerator and the denominator. So numerator goes first, denominator goes second. The next one is a power property. So if we look at this problem, we have log base b of m to the n power. Now, this exponent, this power, can actually go as the coefficient of the log. And that's what this is. So we see that we have n times log b to the m. So this is called the power property. And the last one is the change base property. So if we have log base c of a, we could create an equation with a different base. So we could say this is log base b of a over log base b of c. Okay, so now let's look at some examples. Now the first part that we're going to be doing is we're going to be going from from multiple logarithms, and what our goal is to combine it into one single logarithm. So to start with, we have a minus sign. And remember that if there's a minus sign, that means that this is the quotient property. So what I could say is log base 3 of 27 minus log base 3 of 81 is equal to log base 3 of 27 over 81. So 27 over 81 can be reduced. If I divide the top and bottom by 27, this is equal to log base 3 of 1 over 3. Now 1 over 3 can be written as a negative exponent. So I'll do this on the side here. 1 over 3 is the same as 1 over 3 to the first power, which is the same as 3 to the negative 1 power. So this is equal to log base 3 of 3 to the negative 1 power. Now we could actually use a definition property for this right here. So remember that if you have log base of the base, it's just equal to the exponent. So this is equal to negative 1 because the log 3 and the 3 reduced each other out. Next, we're going to go into problem B, and we have 1/2 log 8 x minus 7 log 8y plus log 8z. So what we're going to do is we're gonna take this in steps. We have a minus here, so what that means is that this is going to be quotient between these two. And then we have addition, and what that means, that's going to be product. We also have a coefficient, and remember that a coefficient in front of a log is the power of that, the power of the log. So right here we have another coefficient, and it's the power. And we're going to actually start there. So what we're going to do is we're going to rewrite this as log 8 x to the 1/2 power minus log 8 y to the 7 power plus log 8 to the z. So these two are minus, and then we have an addition. So I could combine this. I could write this as log 8. I could write x to the 1/2 over y to the 7 times z. Now x to the 1/2 can be written as a radical. So this is the same as log 8 square root of x times z over y to the 7th power. And that is our solution. So we went from expanded form to a single logarithm. Okay, so now that you have those examples, I want you guys to pause this video and work on problems 1, 2, and 3. And again, we're combining all of these into a single logarithm. So for number 1, this is subtraction. So what I'm going to be using is the quotient property. So I'm going to have log of 36 divided by 4. Which becomes log of 9. And that is your solution. For number 2, you have coefficients here and here, and then we have addition. So that addition means that we're going to use the product property. These coefficients mean that we're going to use the power property. So if you imagine that these coefficients are the exponents of the variables, I could write this as log 6 x to the 4th power plus log 6 y to the 7th power. Now I could use the product property and combine these as log 6 x4 times y7. And that is your solution. Then for number 3, we're going to do the same thing. So we have addition. That means that this is going to be the product property. And then we have coefficients. So let's start with the coefficients. Give the variable the coefficient as an exponent. So this becomes log 3 x squared plus log 3 y to the 1/2 plus log 3 z. Then what we're going to do is we're going to combine these together. So we're going to have log 3 x squared times, now y to the 1/2 is the same as the square root of y, and then times z. And I could easily clean this up as log 3 x squared z square root of y. And that would be your solution. Okay, next what we're going to be doing is we're going to go from a single logarithm and we're going to expand on these logarithms. So let's start with the first example, log 6 of 36x. So let's start by expanding this. Now this is multiplication here, so I could expand this using the product property. This is equal to log 6 36 plus log 6x. Now 36 is the same as 6 squared, so I could write log 6 squared plus log 6x. Using a definition property, the log base 6 with the base 6 cancel each other out, and you're left with 2 plus log 6x, and that is your expanded form. And the last example, I'm going to just kind of walk you guys through their steps. So we have log 7 x squared times y divided by z to the 4th power. So you're using the product property between x squared and y, and then you were using the quotient property with z to the fourth. If you start with the quotient property, we could separate this. So we have log 7 x squared y minus log 7 z to the fourth power. Then right here you could use the product property to expand this. So we have log 7 x squared plus log 7 y minus log 7 z4. And then we could use the power property to give these exponents as coefficients. So this 2 goes in front and this 4 goes in front. And we have 2 log 7x plus log 7y minus 4 log 7z. Okay, so now let's go through some of these problems together. So we have division here, and we're going to use the quotient property. So we're going to have log 4 of 39 minus log 4 of 26. And that's your solution. Here we have multiplication, so we're going to use the product property. So then we're going to have log 8 of x plus log 8 of y squared. And then what we're going to be doing is we're going to use the power property where we're going to put this exponent as a coefficient. And we have log 8 of x plus 2 log 8 of y. And that will be your solution. And the last one, I guess the most challenging one, we have multiplication and we have division. Let's start by separating this as a quotient property. So we're just separating the numerator from the denominator with subtraction. So we're going to have log 2 of x3 y5 minus log 2 of square root z. Then we're going to use the product property here. So then we're going to have log 2 x3 plus log 2 y5 minus log 2 z to the 1/2 power. And the last thing is giving these exponents, these powers, as coefficients using the power property. And we get 3 log base 2 of x plus 5 log base 2 of y minus 1/2 log base 2 of z. And that is your final solution. So 3 log 2x plus 5 log 2y minus 1/2 log 2z. Alright guys, so hopefully these videos helped with this lesson. Please take your time with these problems and do your best in writing your answer in Kami and through the fillable document. Yeah, thank you.